Okay, today we're going to look at solving this equation. 1/2 x minus 2/3 equals 3/4 x minus 4/5. This equation can be intimidating for a lot of students because of all the fractions. So I'm going to show you a trick today for dealing with all these fractions so that you actually can just get around them, so you don't have to deal with them. Whenever you have an equation with multiple fractions, the trick for dealing with that is to multiply both sides of the equation by the common denominator. So you look at all the fractions in your equation on both sides and ask yourself, what is the common denominator for all of these fractions? And this one's kind of a tough one. We have a denominator of 2, 3, 4, and 5, and we want to find a common denominator for all four of those numbers. And what I try to think of is, and so we're looking at all four of these numbers here, what I try to think of is, what is the smallest number that can be divided by each of these? What's the smallest number that can be divided by 2 and 3 and 4 and 5? That will be my least common denominator, which I'm abbreviating here as LCD. And if you think about it for a minute, hopefully you'll come up with the answer of 60. That actually is the smallest number that can be divided by 2 and 3 and 4 and 5 evenly. So 60 is our common denominator. We're going to take that common denominator of 60 and multiply it to both sides of the equation. All right, so it's going to look like this. We're going to multiply 60 to the left-hand side, 60 to the right-hand side. And what should happen after you simplify is that the fractions should just disappear, and you don't have to deal with the fractions. So I guess we're going to have to deal with them initially, because the 60 has to get multiplied to each of these fractions, but what's going to happen is once they interact with each other, the fractions are gone, and then we can solve the equation without having any fractions in our way. So multiplying 60 to the left-hand side, we'll have to distribute. We'll have to do the same thing on the right-hand side. We'll distribute. And because the 60 is having to go up against all these fractions, I find it helpful to think of the 60 as a fraction as well. And you can think of it as a fraction by writing it as 60 over 1. So we'll multiply that to the left-hand side and to the right-hand side by distributing, and so the 60 over 1 gets multiplied to each term on the left-hand side and each term on the right-hand side. So we have 60 times 1/2 x minus 60 times 2/3 on the left-hand side. On the right-hand side, we have 60 times 3/4 x minus 60 times 4/5, and in each case, we're writing the 60 as a fraction. The way I like to multiply these fractions together is I like to reduce first before I multiply. And we can reduce by canceling out anything from a numerator to a denominator. So for example, in the first case, with 60 over 1 times 1/2 x, the 2 can cancel with the 60. And what I'll have left over is 30. When I say cancel, what's going to happen really is they're going to divide each other. 60 divided by 2 leaves me with a 30 on top, and the 2 is just gone. Right? We're going to do that with each term here. And so in the second case, what's going to happen is the 3 will cancel with the 60 and leave me with a 20 on top. And the 3 is gone. There is no denominator anymore. I guess I like to say there's no denominator, but that technically isn't true. There is a denominator, but it's a 1. And if the denominator is a 1, we don't have to write that anymore. And so the fraction is going to be gone. We do the same thing to the left-hand side. So maybe pause the video for a second and see if you can figure out how the 60 cancels with the denominator in each case on the right-hand side. Right? So the result you should have come up with is this. Right? So the 4 cancels with the 60 and leaves me with a 15. The 5 cancels with the 60 and leaves me with a 12. So what we're going to do in each of these cases is go back and multiply what's left over from our common denominator to each numerator that we had there to begin with. So for the first example, for the first term, we'll have a 30 left over times the 1 that was already there. In the second example, we have the 20 that's left over times the 2 that's already there. And we'll go back and do that. And in each case, it's over 1, which means we don't have to write that 1. So we're going to get 30 times 1, which is 30, over 1, which is still just going to be 30, and then the x gets copied down. In the second case, we're going to have 20 times 2, which is going to be 40. That's how we get the 40 there. 40 over 1, again, is still just going to be 40. So again, it's no longer a fraction. 15 times 3 is going to be 45 over 1, which is still just 45. The x gets copied down. And then 12 times 4 is going to be 48. 48 over 1 is still just 48. And so we just get all these nice whole numbers, and there's no more fraction. So that's how you handle fractions in your equations. You multiply both sides by the common denominator. We still need to solve the equation, but this should be relatively easy now that the fractions are out of the way. So let's go ahead and solve the equation really quickly here. To solve the equation, we need to get x on one side, everything else to the other side. So I like to start with getting x on one side first. So I'll subtract 45x from both sides. This eliminates it from the right-hand side so that it only exists on the left-hand side. Right? And so we're going to end up getting, when we combine like terms, we're going to end up getting negative 15x. Right? 30x minus 45x is negative 15x. The minus 40 gets copied down. On the right-hand side, the x disappears, and so we just copy down the negative 48. Right? The next step is to get rid of the minus 40 on the left-hand side, and I can do that by adding 40 to both sides. That eliminates it from the left-hand side. And so what we're going to end up getting is, when we combine like terms, we will have the negative 15x gets copied down, the 40s cancel out, and on the right-hand side, negative 48 plus 40 gives me negative 8. And now to get x by itself, we divide by the negative 15 on both sides. Right? We divide because the negative 15 is being multiplied to the x, so we divide to get rid of it. And what we end up getting is x equals negative 8 over negative 15. And whenever you get an answer that's a fraction, you want to make sure you reduce that answer. But 8 and 15 don't reduce with one another. They don't cancel out in any way. But the negative signs can be canceled out. Right? Negative divided by a negative will be positive. So our final answer in simplified form is that x must equal 8 over 15.